Hello everyone, welcome back to my channel. My name is Harsh. I am studying in Sri Venkateswara College of Engineering. Subject Data Structure and Application. Topic Microstructural Studies of Friction Stir Wheels in 2024 T3 Aluminium. First abstract. Friction stir wheels in 7 millimeter thick 2024 T351 aluminum rolled silt material have been completed. Metallurgical hardness and energy distribution X-ray measurements have been performed, which demonstrate that a segregated band microstructure consisting of alternating hard particles rich and hard particle poor regions is developed. Mixed mode monotonic fractures experiments confirms that the observed band microstructures affects the microscopic fractures process. Synaptic band spacing is directly corrected with the welding tool. Advance per revolution. Our results indicates that the opportunity exists to manipulate the friction stir well process perimeters in order to modify the weld microstructure and improve a range of material properties including fractures resistance. First, introduction. The difficulty of making high strength fatigue and features resistant welds in aerospace aluminum alloys. For example, highly alloyed 2XX and 7XXX series aluminum has long inhibited the use of welding processes for joining aerospace structures. Typically, mechanically fastening has been the joining method of choice, except in production of pressures vehicles for rocket propellant and oxidized tanks. Even in pressure wheels applications, heavy weld land must be incorporated to connect for the server nose down resulting from the fusion welding process. Many of the problems with weld and aerospace aluminum from the unforgivable distribution of brittle solidifications products and purity in the weld region. Precision stills welding (FSW) is a relative new technique for making solid-state welding in aluminum. Alloys inarcing results have been obtained when FSW has been used on high-strength aerospace aluminum alloys that are typically difficult to weld. Second one, specimen and the FSW process. In this work, 1.22 m into 2.443 m into 7 thick shirt to 2024 to T3 aluminum was cut into two square pieces. These were fractures that weld together using a tool with a 23.0 diameter should and 8.2 diameter pin. The major process parameters were a rostral speed of 360 rpm and a travel speed of 3.3 mms1 perpendicular to the rolling direction of the sheet. Figure 1 shows a crow size the typical FSW used in the work as shown in figure to connect the crow side of a FSW during process while the fruit side in the direct content with the backing plate and aperture side the crow side. The advantages of reconnecting sides of the wild correspond to locate where the maximum and minimum relative velocities between roasting tools and the new workpiece are observed. Third one, microstructure measurements. To achieve a high construct image of each FSW microstructure difference etching process were used the include killers, chess breakers, checks and HFX. Apology microscopics are taken used to either light microscopes or scanning electronic microscopes (SEM), depending on the size of the features to be characterized. In addition, energy displays X-ray spectrometers (EDX) is used to analyze the chemical composition of the material. Figure 2. This is called figure 2. Presence. Fourth one, relationship between fractures and banded microstructures. As noted in section 1, our structure of the microstructure was motivated by a series of preliminary fractures experiments, specifically a series of mixed mode experiments were performed with true thickness figures, Christ located in the LZ plane along the center line of the FSW t is equal to 0. Since the general planes were independent of mixed mode loading, presence discussion of results. The presence of clearly defined bands in the 2024 T351 microstructure appears to be due to perimeters chosen for the FSW joining process employed. The FSW process required rotational externals of material around the front of the tool. The structure takes place in a very thin layer of material surrounded the tool. Sixth, conclusion. A series of controlled friction steel wheels have been manufactured using 6.25 mm thick 2024 T351 aluminum rolled sheet material. Result from hardness and context EDX measurements clearly show that the friction steel welding process can create a significant banded microstructure consisting of arithmetic hard particles such and hard particles poor religions. Thank you for seeing video.